Now we're going to look at 45-degree angles to the longest slab boundary. Just like with parallel perpendicular, it's important to calculate the maximum number of steps you can take in a run. We know with the parallel perpendicular method, you can take the width of the floor, subtract the 2-foot boundary on each side, and get the maximum number of steps we can take while still observing that 2-foot boundary. So 30 minus 4 is 26. With 45s, your line is going to be much longer. So at a 45-degree angle, our first step plus 35 more steps is 36 steps. We need to know this number prior to making this run. The reason for that is that if we are off by just a few degrees, we'll do 38, we can now take 41 steps. The maximum number of steps we can take is 36. At 41 steps, we're showing that we have taken too many steps. We're taking a number of steps in reporting that are physically impossible to take on this slab. So we need to calculate how many steps we can take before we do this run. Well, the way to do that is to take the width of the work area, which we've already calculated as 26 feet, and multiply it by the square root of 2. So 26 times the square root of 2 is going to be 36 to several decimal places. We're going to round down to the nearest whole number because we can't take a fraction of a step. The margin of error is very slim when doing 45-degree angles. At a 42-degree angle, we can still report 38 steps. So our report will appear as if we'd taken 2 steps into the 2-foot boundary. The margin of error for parallel perpendicular is different. We're at a 90-degree angle, and we can collect 26 steps. We have to be at a 75-degree angle to be able to collect even 1 additional step. And this would be quite obvious physically when doing this test. It's far less obvious when doing 45-degree angles if you're off just enough to show an erroneous test result.